Hello, everybody. We're going to be talking about the composition of matter today. So go ahead, get the things you need for your notes, and let's get started. First thing we want to talk about in composition of matter today is substances. What is a substance? A substance is a type of matter that has a fixed composition. An example of this would be an element. Okay? An element is a substance that is made up of atoms that are all alike. For instance, if we had gold, the element Au, that would mean everything that is about that element, that substance, is nothing but pure gold. There's nothing else mixed in with it. It's what we call a pure substance. The next substance we talk about is a compound. A compound is a little bit different than an element because a compound is a substance where there are two or more different elements added together, but there is a fixed proportion, like that proportion never changes. An example of this would be water. Water's chemical compound is H2O, which means for every two hydrogen atoms, there's one oxygen atom. And this never changes. So water would be an example of a pure substance. The next thing we'd like to talk about are mixtures. What is a mixture? Mixture is a matter composed of two or more substances that can be separated by physical means. That means we can take them apart. All right, they're not attached compound like put together with chemical bonding. And the types of mixtures that these are called a heterogeneous mixture. All right, a heterogeneous mixture is a mixture in which different materials remain distinct. Think of a mixture of salt and pepper. You can see the salt, you can see the pepper. We can separate those, even if we needed to pick a grain of salt out grain by grain with the tweezers, or we could use something like a sifter because pepper is very light. You can blow the pepper flakes away and leave the salt behind. That would be an example of how we would separate that with a physical means. Another example would be salad dressing. Italian, you have oil and vinegar mixed together. And they separate if you don't shake them up. You just set it there and they separate out, okay? They remain distinct. So how about ranch dressing? Would ranch dressing be a heterogeneous mixture or would it be some other type? Actually, if you look very closely at your ranch dressing, you can see that it's actually a mixture of many different things, and we could separate those out with a physical process. Okay. Again, although it's mixed well, there are no combining reactions, and that's the thing you have to remember about a mixture. All right, especially a heterogeneous mixture, there are no combining reactions. They're just stuff that's mixed together, like all the toys in your brothers and sisters' rooms in their toy box. It's just tossed together. Okay. Next thing we'd like to talk about are heterogeneous mixtures, the different types of heterogeneous mixtures out there. One of these types is called a suspension. A suspension is a mixture of liquid and solid particles that settle. A great example of this would be a muddy river. Okay, so if you have a muddy river and it's entering the clear ocean, notice right here, this is an example. The muddy river water is all stirred up as it's moving swiftly down, but over here on the sides, the water has stopped moving so swiftly, and because it's not moving, it's not carrying those sediments, those particles anymore, and so they have given time for it to settle down to the bottom. So again, that would be a suspension. Think of muddy water in a jar. You shake it up, you set it down, and all this stuff settles out, and then you have clear water on the top, which is why at home, if you have mud puddles, if you leave them alone, the water in the top looks clear, but as soon as you step in it, it all becomes cloudy and muddy again. Okay, that is a suspension. Also, one of the things we talk about are colloids. What is a colloid? A colloid is a mixture of liquid and solid particles that will not settle if left standing. Okay, it just stays mixed together no matter how long you leave it standing. Examples of these would be milk, paint, fog, smoke. Okay, they don't separate out. There's some other examples in there, some Jello, butter. One of the things you can do is you can identify a colloid by shining a light through it. If this light beam is scattered or reflected, it's a colloid. Okay. This is all what we call the Tyndall effect. All right. The Tyndall effect is again the scattering of a light beam as it passes through a colloid. Okay? And over here in the corner, you see a picture of that. Two different liquids that are colloids, and as you shine the beam into it, you can actually see the light beam scattered as it goes through those colloids. Okay, and one obviously is much more reflective quality and scattering quality than the first one does. Next, we want to talk about homogeneous mixture. All right, this is a different type of mixture. We talked about heterogeneous. Hetero means different. Homo means same. So these are the same basic mixture. Okay. This mixture remains consistently and uniformly mixed, and it has particles that are too small to see with the microscope, which means we can't separate them out with the naked eye. That's a homogeneous mixture. Another name for that would be a solution. A solution is another name for a homogeneous mixture. Kool-Aid, tea, coffee, all these things are mixtures, but they're so small that we can't separate them out, right? They're constantly and uniformly mixed, okay? So they are different than a colloid. Okay, a colloid is a mixture where we can separate the things out of it, right? The solution is a homogeneous mixture. Here's a flow chart that could be really helpful to understanding how everything is broken into it. We have matter at the very top, and then we have, if it's pure, if it's by itself, nothing else, we go to the left side. And if it's got mixture, mixed with other things besides itself, all right, we have those over here on the left side. We have elements and compounds. Remember, compounds are atomically combined with a fixed ratio. It's almost impossible to get Kool-Aid to be a compound. It is, unless you go down to the atomic level, because you may have 1 or 2 grains of sugar difference, you may have 1 or 2 grains of the dye. There's too many different factors in there, and it's not a compound because it's not a fixed ratio. That's what the difference there is between a compound and a homogeneous mixture. Homogeneous mixtures are also known as solutions, and then here are some different examples of that. Okay.